China is building the world's largest AI data centers in remote desert regions, and the scale is almost incomprehensible. These aren't small server rooms. They're computing complexes designed to house over 115,000 high-end NVIDIA chips. You heard that right. To put that in perspective, that's more than 400 times the computational capacity of Frontier, the world's fastest supercomputer. China is building this not in one location, but across dozens of facilities in Xinjiang, Inner Mongolia, and Qinghai, and it's happening right now. Let's see why they chose the desert and what it means for the future of artificial intelligence. You're standing at the edge of understanding a geopolitical shift that most people haven't noticed yet. China has decided that artificial intelligence dominance requires one thing above all else: computational power. Raw, undeniable, overwhelming computational power. And they're willing to spend hundreds of billions of dollars to ensure they have more of it than anyone else on Earth. The numbers alone should terrify Western governments. 115,000 NVIDIA H100 chips spread across dozens of data centers in the desert. Each of those chips delivers 4 petaflops of computing power. That's 4 quadrillion calculations per second per chip. Multiply that across the entire planned deployment, and you're looking at roughly 460 exaflops of total computing capacity. The Frontier supercomputer, the most powerful computer in the world, delivers 1.1 exaflops. You heard that right. China's desert data centers will be over 400 times more powerful. But the shocking part isn't just the scale, it's the speed. In 2 years, China moved from announcing the East Data, West Computing Initiative, a government mandate to move data processing from crowded eastern cities to resource-rich western regions, to actively breaking ground on dozens of major facilities. No environmental impact statements dragging on for years. No public hearings. No regulatory delays. Just decision, mobilization, and execution. The location choice reveals the strategy. Xinjiang, Inner Mongolia, and Qinghai aren't randomly selected. These regions sit on top of vast renewable energy resources. Solar farms and wind turbines generate electricity so cheaply that power costs become almost negligible. The high-altitude climate naturally keeps server temperatures down, which means you don't need expensive cooling systems consuming billions in electricity. Land that would cost a fortune in Shanghai or Beijing costs almost nothing in the desert, and the isolation provides security. No foreign observers, no interference, no distractions. Just computational capacity focused entirely on training the next generation of Chinese artificial intelligence models. The US government understands the threat. Since 2022, they've banned NVIDIA from selling their most advanced AI chips to China. But China is finding workarounds. Gray markets, existing stockpiles, homegrown alternatives. The construction continues regardless. This is the moment when the AI race stopped being about who has the smartest researchers and started being about who can build the biggest computing infrastructure first. But understanding why the desert works reveals something even more crucial about what China is actually training in these facilities. The East Data, West Computing strategy. You need to understand the problem China was trying to solve, because the solution reveals how they're thinking about artificial intelligence differently than the West. China's eastern cities, Shanghai, Beijing, Shenzhen, are where the money is. That's where the tech companies operate. That's where the users are. But those cities have a massive problem. They're running out of power. Data centers consume obscene amounts of electricity. A single facility housing tens of thousands of GPUs can demand as much power as a small city. Eastern China's electrical grid is already strained. Adding another massive data center to Shanghai doesn't just require more power plants, it requires retrofitting the entire infrastructure. And that takes years, maybe decades. By that time, China's competitors will have already trained the next generation of AI models. So the government made a radical decision. Instead of trying to squeeze more computing power into the East, they'd move the computing power to where the energy already exists. The western provinces, Xinjiang, Inner Mongolia, Gansu, Qinghai, are vast, sparsely populated, and energy-rich. Wind farms stretch across Inner Mongolia for hundreds of miles. Xinjiang's solar potential is enormous. Coal reserves sit untouched. And the population is small enough that no one cares if you build a massive data center that consumes as much electricity as a city of 1 million people. But moving computation to the west created a new problem: latency. If your data center is buried in the Gobi Desert and your users are in Shanghai, that's 1,000 kilometers away. Data has to travel that distance at the speed of light through fiber optic cables. For some applications, that's fine. Training AI models doesn't require real-time responses. You can tolerate delays measured in milliseconds. But for other applications, voice assistants, autonomous vehicles, real-time image processing latency kills the experience. So China built the solution: ultra-fast fiber optic networks connecting the desert data centers to eastern cities. These aren't normal internet cables. These are specialized fiber connections, capable of moving petabytes of data across thousands of kilometers with microsecond-level delays. The infrastructure itself cost tens of billions of dollars. But it solved the problem. Now computation could happen anywhere in the cheap, energy-rich West, while still serving users in the expensive, power-constrained East. This wasn't just infrastructure planning. This was strategic repositioning. China realized that whoever controlled the computational backbone of Asia would effectively control Asian AI development. So they built that backbone themselves, government-owned, government-operated, under complete government control. And the specific locations they chose reveal something even more disturbing about what they're building in those deserts. Why? The desert is perfect for AI training. You're looking at a map of Western China, and the locations where China is building these data centers aren't accidents. Every single one was chosen because it solves a problem that makes large-scale AI training possible. The first problem is power. Data centers built for training large language models consume staggering amounts of electricity. A single facility with 50,000 GPUs running 24 hours a day can demand 300 to 500 megawatts of continuous power. That's enough electricity to power 300,000 homes. You heard that right. 300,000 homes worth of electricity every single day just to keep the servers running. Eastern China can't provide that power reliably. Their grids are already maxed out. But Xinjiang and Inner Mongolia sit on top of infinite renewable energy. Wind turbines spin constantly across the Mongolian plains. Solar farms in Xinjiang generate power at costs that are literally 1/3 what they cost in the East. And unlike solar in temperate regions, Xinjiang's high-altitude desert gets more than 300 days of sunshine per year. The economic math is irresistible. A data center in Xinjiang can source its power for a fraction of what it would cost anywhere else on Earth. But power is only part of the equation. The second problem is cooling. Those 50,000 GPUs generate an enormous amount of heat. Each GPU can draw 700 watts of power, and nearly all of that becomes heat. That's equivalent to running industrial furnaces in your facility 24 hours a day. You have to remove that heat somehow, or your servers melt. Traditional air cooling systems are wildly expensive in the desert because you'd be running air conditioning at full capacity constantly. But here's where the location choice gets clever. The desert at high altitude is cold. Yiwu, where one of the largest facilities is being built, sits at over 4,000 feet elevation. Night temperatures regularly drop below freezing, even during summer months. China is using evaporative cooling and liquid cooling systems that leverage the natural cold to dissipate heat far more efficiently than any air-conditioned facility in the East could manage. The third problem is land. A data center with 100,000 GPUs requires massive physical space. Cooling systems, power distribution, backup generators, fiber optic termination facilities, these are sprawling operations. In Shanghai or Beijing, that footprint would cost tens of billions of dollars. In the desert, land is essentially free. You can build facilities that are not just larger, but architecturally optimized for efficiency, without worrying about real estate costs. And the fourth problem, the one that Western governments are genuinely alarmed about, is oversight. These facilities are in remote desert regions where foreign observers don't have easy access. The Xinjiang government is particularly restrictive about foreign visitors. No journalists, no inspectors, no watchdog organizations documenting what's happening. China can build, operate, and expand these facilities with complete control over information. No leaks, no regulatory challenges, no public scrutiny. It's the perfect location for an artificial intelligence arms race. But understanding the infrastructure is only half the story. The real power lies in what's actually happening inside those facilities. Building the computational backbone. You're stepping inside one of these facilities now, and what you're seeing is something most people on Earth will never understand. Rows upon rows of server racks stretch across warehouse floors the size of football stadiums. But this isn't data storage. This isn't video streaming infrastructure. This is something fundamentally different. This is a GPU cluster designed to train artificial intelligence models at a scale that has never been attempted before. Each server rack contains dozens of NVIDIA H100 chips stacked together and connected by ultra-high bandwidth interconnects. The H100 isn't a normal graphics card. It's purpose-built for artificial intelligence. The chip contains 80 billion transistors, more computing power than entire supercomputers from just a few years ago. When you stack thousands of these chips together and connect them with fiber optic cables running at terabits per second throughput, you're creating something that transcends traditional computing. You're creating a single unified computational entity capable of processing trillions of parameters simultaneously. The architecture is the key to understanding why this matters. In a traditional data center, servers are connected loosely. Data moves between them through normal network protocols. There's latency. There's bottlenecks. But in an AI cluster designed for training, the GPUs need to communicate at microsecond speeds. They're not sending messages back and forth, they're collectively computing on the same problem simultaneously. NVIDIA solved this with NVLink, a direct chip-to-chip interconnect that delivers 900 gigabytes per second of bandwidth between GPUs. That's fast enough that thousands of chips can act as a single unified processor. But here's where China's approach gets strategic. They're not just buying NVIDIA chips, they're also integrating domestic alternatives. Huawei's Ascend processors. Custom chips designed specifically for AI workloads. The reason is simple. The US banned NVIDIA from selling their most advanced chips to China, so China is building redundancy into their infrastructure. If they can't get enough H100s, they'll use Huawei chips. If those become unavailable, they'll develop their own. The facility itself is designed to accommodate multiple chip architectures simultaneously. The cluster organization is crucial. You don't just randomly arrange 115,000 GPUs and hope they work together. They're organized into hierarchical groups. Small clusters of 8 to 16 chips are connected together into pods. Pods are connected into larger groups. Those groups form the overall facility cluster. At each level, specialized switch hardware manages communication. It's like building a nervous system for a digital brain. And the scale of what they're building is genuinely staggering. When this infrastructure is fully operational, it will be capable of training AI models with parameters measured in the trillions. Models that would take Western companies months to train will be trainable in weeks. The competitive advantage isn't just technical, it's temporal. Speed becomes the deciding factor in the AI race. Then came the engineering challenge that determines whether any of this actually works. The cooling crisis. You've just realized the fundamental problem with building a data center containing 115,000 GPUs in the desert. Each of those chips generates 700 watts of heat. Multiply that across the entire facility, and you're looking at roughly 80 megawatts of continuous heat generation. That's equivalent to running an industrial blast furnace the size of a building, 24 hours a day, 7 days a week. You have to remove that heat, or the chips literally melt. Traditional air cooling is useless. You'd need to run industrial air conditioning systems so powerful that they'd consume more electricity than the GPUs themselves. That defeats the entire purpose of building in the desert, where power is cheap. So China is deploying cooling technologies that were theoretical just 5 years ago. Immersion cooling is the breakthrough. Instead of air passing over chips to remove heat, the entire chip is submerged in a special dielectric fluid, essentially a non-conductive mineral oil. The fluid absorbs heat directly from the chip surface and carries it away to cooling radiators. The advantage is staggering. Immersion cooling systems can dissipate 10 to 20 times more heat than air cooling, using a fraction of the energy. The chips run cooler, last longer, and the facility consumes far less electricity. But immersion cooling introduces new challenges. The fluid has to be circulated continuously. The cooling loops have to be meticulously engineered to prevent hotspots. And if the system fails, if the cooling fluid stops circulating for even minutes, the entire cluster overheats and shuts down. So China is building redundancy. Multiple independent cooling loops, backup pump systems, monitoring systems that can detect temperature anomalies before they become problems. The most advanced facilities are using liquid cooling with water-based systems. Water has vastly superior thermal properties to oil. It absorbs heat more efficiently. But water is corrosive to electronics. So the cooling loops are completely isolated from the chips themselves. Heat exchangers transfer thermal energy from the chip cooling fluid to the water cooling system. The water then circulates to massive radiators, where the heat is finally dissipated into the desert air. And here's the critical insight. The cooling system consumes somewhere between 40 and 50% of the total electricity budget of the facility. You heard that right. Nearly half of all the power you're generating is used just to keep the chips cool. That's why the desert location is so crucial. In the desert, nighttime temperatures drop dramatically. The temperature differential between hot cooling fluid and cold night air is enormous. That differential is what makes efficient heat dissipation possible. But solving the cooling problem revealed an even more critical bottleneck: the power delivery system. You're looking at something most people have never considered. How do you actually deliver power to a facility consuming 500 megawatts continuously? That's not an abstract question. It's an engineering nightmare that determines whether these entire projects are even feasible. A single power plant generates 1,000 to 2,000 megawatts maximum, so a 500 megawatt data center is consuming a quarter of an entire power plant's output. You can't just plug it into a normal electrical grid. The facility has to be connected directly to power generation sources, solar farms, wind turbines, or power plants through dedicated high-voltage transmission lines. And those lines themselves have to be built. They cost billions of dollars. China solved this by integrating renewable energy directly into the facility design. Instead of building a data center and then trying to source power, they built the power generation first. Massive solar arrays spread across the desert, connected directly to the data center. Wind turbines scattered across nearby plains. Battery storage systems that can provide power during nighttime hours or cloudy days. The entire facility is designed as an integrated power-to-compute system. But here's the engineering challenge. Power delivery to individual server racks requires converting the high-voltage power from transmission lines into the precise voltage and amperage that each GPU cluster needs. NVIDIA H100 chips operate at relatively low voltages but consume enormous currents. You need specialized power distribution units capable of converting power with 95% efficiency while handling fluctuations in demand. If the conversion is inefficient, you're wasting tens of megawatts of power as heat. If there's voltage instability, you shut down the entire cluster. So China is deploying the most advanced power conditioning systems available, direct current power delivery, which is more efficient than alternating current for data center applications. Distributed power electronics that convert power at the server level rather than at facility level, reducing losses. Real-time monitoring systems that adjust power delivery based on GPU demand, optimizing efficiency second by second. The redundancy is military-grade. Multiple independent power feeds from different sources. Battery backup systems capable of providing power for hours if the primary sources fail. Automatic load balancing that can shed non-critical computing tasks if power becomes constrained. The facility is designed so that a single power failure never takes down the entire cluster. And here's what makes this genuinely frightening from a strategic perspective. A facility this size, with this much renewable energy generation capacity, can literally operate independently. It's not dependent on China's national power grid. It's a self-contained computational entity. That means it can operate during power crises, during wars, during any scenario where normal infrastructure breaks down. This isn't just a data center. This is critical national infrastructure, disguised as a commercial facility. But all of this power, all of this cooling, all of this hardware, it means nothing unless the data flowing through it is actually useful. What these centers actually train. You need to understand what's actually happening inside these facilities, because the real power isn't in the hardware, it's in what the hardware enables. These data centers exist for one purpose: training large language models at a scale and speed that gives China an insurmountable advantage in artificial intelligence. A large language model is essentially a mathematical function with trillions of parameters. ChatGPT has roughly 170 billion parameters. The next generation of models will have trillions. Training those models requires processing enormous datasets, billions of text documents, images, videos, and adjusting trillions of mathematical values to maximize the model's ability to predict the next word, recognize objects, or perform reasoning tasks. That process takes weeks or months on traditional computing infrastructure. But a facility with 460 exaflops of computing power can compress that timeline dramatically. A model that takes 3 months to train on conventional hardware might take 3 weeks in these desert data centers. You heard that right, 10 times faster. And in artificial intelligence, speed determines dominance. The company that can iterate 10 times faster cycles through more experiments. They discover better techniques faster. They deploy improved models to the market sooner. They capture market share before competitors even finish their first training run. China is training models specifically designed for Chinese language and Chinese cultural context. DeepSeek, a Chinese AI startup, has already deployed models trained on domestic infrastructure that compete directly with OpenAI's offerings. But that's just the beginning. These desert facilities will enable training of multimodal models, systems that can process text, images, audio, and video simultaneously. They'll enable specialized models for industry applications, autonomous vehicles, manufacturing optimization, financial forecasting, surveillance systems. The speed advantage creates a compounding effect. Faster training means faster iteration. Faster iteration means better models. Better models attract more users and generate more data. More data enables even better models. Within 2 to 3 years, Chinese AI models trained on this infrastructure could be demonstrably superior to Western alternatives, not by a small margin, by fundamental orders of magnitude. But here's what Western governments understand, and what keeps them awake at night. These aren't just commercial AI systems. These are government-controlled infrastructure. Every model trained here answers to Chinese strategic interests. The computing power is a national asset, deployed according to state priorities. And right now, the state priority is clear: achieve absolute dominance in artificial intelligence before any other nation can match the computational capacity. And that competitive pressure is creating a geopolitical crisis that's about to explode across the entire world. Why this moment determines the next decade of AI. You're standing at the exact moment when artificial intelligence dominance became a matter of concrete computational power. The desert data centers China is building right now will be operational by 2026. When they are, everything changes. A model that takes American companies 3 months to train will take China 3 weeks. You heard that right, 10 times faster. In artificial intelligence, speed is supremacy. The nation that iterates fastest wins. They discover better techniques first. They deploy superior models to market before competitors finish their first attempt. They capture the entire market before anyone else can respond. This isn't about commercial competition anymore. This is about which nation controls the technology that will define the next 50 years. AI determines economic power, military capability, and technological leadership. China understands this perfectly. That's why they're spending hundreds of billions building these facilities. That's why they're moving at speeds Western governments can't match. The United States tried to stop it with chip bans. It won't work. China is finding alternatives. The construction accelerates regardless. By 2026, the world's largest AI training infrastructure will be under Chinese government control. The models trained there will reflect Chinese interests. And they'll be better than anything the West can produce, because they'll have been trained on more computational power than any competing facility can match. This isn't a future scenario. This is happening right now. And by the time the rest of the world realizes what's at stake, it will already be too late to catch up.